Okay, so using a compound interest question and using the graphic calculator, what I find actually useful is to know and understand the initial compound interest formula. This is explained in another video, what each value means, the K, the N, the R, and so on. It's not a difficult formula to use. It might actually be easier to use than the application, than the finance app, but if you want to use the finance app, this is also helpful, especially if you're missing other values like the rate or the present value. The application makes it a bit easier. So the question goes, Rachel invests £6,000. So this is kind of key on we're heading to compound interest a bit, and a bank that pays an interest rate of 2.3 and compounded monthly. So immediately we're seeing interest rate, we're saying compounded monthly, so we're talking about compound interest. The first question is, how much does she have in a bank after 8 years? My first tip is to actually write all the values you have. So the present value in this case is your 6,000. So she starts with 6,000. That's the present value. The rate is 2.3. It's compounded monthly, which means your K is going to be 12. Again, if you're not sure where this comes from, this is in another video. This is 12, and we're looking at the period after 8 years. So this will be 8. What's nice with the app is that the way you put in the values is quite direct. This will always be your N. This will always be your rate. This will always be the present value as we know it. This will be 0. This is what you need to find. So we'll just put a question mark here. This will always remain as 1. And this will always be your K value. So it's once you figure out how to find all of these letters, it's really easy to convert it in the calculator. So in this case, this is going to be 8. This is going to be 2.3. We have 6,000. We need to find that, and the K is going to be 12. So we go to the calculator. 8, 2.3. One thing to point out is the negatives. So the calculator, if you're trying to find one, if you're putting in one value and then any one of these as well, one of them, because you're always using a pair, either the present value or the future value or the present value PMT and so on, one of them will always be negative and one of them will be positive. You will just ignore the signs when writing your final answer, but the whole idea of what does it mean when it's negative or positive, basically negative is more of if you're investing in a bank, if you're taking money out of your account, then it's better to put the amount as a negative. But when you write your final answers, it won't be a negative. So it's 6,000 here, we have 0, and then we have compounded monthly. And then in order to solve, you have to press on alpha and then enter, and that will help you solve. So you can see the solve written in green. So you go to the value that you need to find. We need to find the future value. You click on alpha and then enter, and that will give you the answer. So 7,210.82. So we have 7,000.82. So rounded to 2 decimal places. So that would be finding the future value. Now it tells you how long will it take for her money to double. Doubling the money means if she starts with 6,000, you want it to double to 12,000. So that's your goal. You don't know how many years that's going to be, so that will be missing, but the compounding and the interest, everything is going to be the same. So in part B, this is missing. So we go back here. We know that we wanted the future value is always going to be positive, so we want the investment to double. We go here, you can clear it and then click on alpha and solve, and it's going to be 30 let's say 30.2 years. So this is where the calculator is more helpful than using the formula, because it's just much easier to deal with it than actually dealing with exponents. This is going to be a bit tricky to deal with. You'll have to use logarithms and so on. So this is just much easier to use. Converting from compound to the calculator is really easy if you can figure out how to use these values. Everything converts nicely into here, the N, the R, the PV, and the 1 and the K. Regarding the negatives and so on, I'll just show you what happens if you don't write a negative. If you try and solve it now, it's going to give you an error. If you read the error, values entered are not allowed in the function. If you click on number 2 to go to, basically the idea is if you're doing present value, future value, any pair of these, one of them has to be negative. That's how the calculator operates. So logically, the 6,000 has to be negative because you're taking money out of the bank. But let's say maybe you want to write this as negative, the formula still works. Eventually, when you write your final, so it still works as 30.2. Eventually, one of them has to be negative. The most logical one is the